All right, so the first test you're going to run is, do you want to find out, do the different levels of religiousness, is there a significant difference between how religious a person is, that's your one, two, three groups, when it comes to their life expectancy? So you go to Analyze, you go to General Linear Model, you go to Univariate. Okay, your dependent variable is your life expectancy, right? And your group IV for your ANOVA is your religiousness. So 1 means not very religious, 2 means that they're moderately religious, and 3 means that they're very religious. And we're going to do a post hoc test, Tuki Tuki. That'll tell us where the group differences are significant. And we click OK. Bam. So here's your first output. This is your IV group for religiousness, and it tells you how many people are in your not very religious. There's only 1. Moderately religious, there's 6. And in your very religious, there's 3. I'm sorry, there's 4. There's only 11 people in your study. If you want to, you can go ahead and put 60 people in there. And then here's their means, right? So 65-year average for the not very religious, 71 years for moderately, and about 82 for very religious. This is your Levine's test. It is checking to make sure that the variance between your IVs is relatively the same, and it is. If this significance number was less than 0.05, you could not use this test. But that's not a problem with you. You're golden, okay? And then here's your money. Get out of here. Hold on. Please hold. Thank you for holding. So here's your money. This is your ANOVA, your between group test, okay? So you only look at the corrected model, and your F test statistic is 14.7, which is really big, which is going to give you a very small significance, 0.02. This is less than 0.05, so you get to reject the null hypothesis, which states, what does the null hypothesis state, Randy?
Whether the data was less than 0.05, and the 0.05 significance level.
That part is correct, but what does all null hypotheses say the same thing? What do they say?
That that there's significance in the data.
Partially correct. All nulls say the same thing, that there is no difference anywhere. So your null here would be there is no difference between how religious a guy is and how long he lives, okay? This says just the opposite, that yes, there is a significant difference between your 3 levels of religiousness when it comes to how long they're going to live. So that's good, okay? So that's your first test. Oh, and then you want to look at your eta squared. This is your effect size. That means about 78% of the variance in their life expectancies can be explained by year 1 IV, by how religious a person is. That's your effect size. Your power is pretty close to 1, so that means your test is very, very strong and it's very believable. Okay, got it. That's your first test. All right, your second test, I would suggest that you do a correlation matrix just to find out which of your variables is related to which of your other variables. So we're just going to put them all in there. Please hold. Okay, so this is going to give us a correlation between all of these different variables, and then we'll take a look at these. So here's your health variable. So health compared to social life, it's not significant, right? You got to look at the significant levels. Anything that's less than 0.05, you got a serious relationship. So health and marriage happiness, very strongly correlated. Health and alcohol use, very strongly correlated. Health and living with a roommate, very strongly correlated. Health and life expectancy, very strongly correlated. So you got a lot of strong correlations here. So let's look at the ones that are not correlated. Social life and health are not correlated. Please hold. I feel better. So social life and health are not related to each other. Okay, so what this is saying is don't worry about your social life. It has nothing to do with your health. Your social life and marriage are not related, right? These significant numbers are not less than 0.05. So that means none of these really depend on social life. So in other words, social life doesn't have much to do with how long you're going to live. But marriage does, except for social life, right? Marriage is very important because it's significant all the way across, except for with social life. Alcohol use is very significant all the way across, again, without social life. So it looks to me like everybody's strongly correlated except for social life. That's it. MGZ out. So lastly, you're going to try to predict which one of these IVs, health, social life, marriage, alcohol use, roommate, is the best predictor of how long a person is going to live. Okay? Now, you already know back from the ANOVA that people that are more religious will live longer. Okay, we already found that out on the first test. So here's your last test. We're going to go to analyze, regression, linear, and you're going to try to predict life expectancy with your health variable, your social life variable, your marriage variable, your alcohol use, and your roommate. So this is going to tell you which one of these is the strongest predictor of how long a person's going to live. And you should look at these too because it's a, and we look at the residuals. Plots, don't care about plots. Options, don't care about options. And then you click OK. So with your last test, your multiple regression model, this is model number 1. Here's your IVs, roommate, social life, alcohol, health, marriage. Your DV is life expectancy, okay? Whoa, look at you. Your R square, this is what you look at. That means 85% in the variance of your life expectancy can be explained by your model, which is really, really good, okay? So that means you could practically predict when a person is going to die by looking at their roommate, social life, alcohol use, health, and marriage. So this is a very strong model. That's your R square. And it's a significant regression because they run a ANOVA on the regression residuals, and it's less than 0.05, which we kind of knew anyway because your R square is so high. But here's your important thing. You look at the beta weights of each variable. Okay? So beta weights will tell you which one is the most significant. Actually, none of these are significant. That's interesting. You're not going to put that in there, though. Note to Randy, do not put significance on the beta weights. You're just simply going to list the beta weights. So that means health is 0.184. Your number one predictor is roommate, because the beta weights tell you. That means that roommate is much stronger predictor than the rest of them. Number 2 is marriage. Number 3 is alcohol use. Number 4 is their health. And pulling up the rear, the least important is the social life, which kind of agrees with what your other one says. Okay? So, and they're not, none of them are significant, so, but don't put that in there, I'll just blur it. Which means that none of this is worth anything. You couldn't pass it through. But now your correlation, your partial correlations, they relatively tell you how strong each one of these is compared to the other ones, and they should agree with the beta weights, and they do. And this is your collinearity. Collinearity checks for if 2 of your IVs are acting identically, that's bad. Because if they're acting identically, how do you know which one of the IVs is affecting the DV? You can't. But you don't have that problem here. Your collinearity statistics are well within the range, so you're good. And that's about it. So on your PowerPoint, you're going to put your descriptives box, your Levine's test box, and your ANOVA box. This is your test between subjects. So your descriptives box, you can talk about the means of the different groups when it comes to this is their average lifespan, and this is the different groups of their religiousness. The Levine's test, you're going to mention that the significance is not less than 0.05, therefore it did not violate the assumption of homogeneity variance. In other words, the variance between the 3 different religious groups are pretty much the same, which is good. And then the last thing you're going to talk about is your corrected model F, which is a big F, is 14.7, which produced a small significance value, a small p-value, which means you get to reject the null that states there is a significant difference between life expectancies depending on which religious groups they're on. And your eta squared is 0.786. What that means is that 78.6% of the variance between life expectancies can be explained by which religious group they're in. Okay? Boom. And your power is almost 1, so that means your test is bulletproof, baby. That was the first test. Second thing you're going to put in your paper. I would just put the whole table in there and just talk about everything that's related. Everything is very strongly correlated except for anything to do with social life. Okay, so all your IVs are strongly correlated with each other except for social life. Got it? Lastly, with your multiple regression, you're trying to use these IVs to see which one is the best predictor for life expectancy. Okay? And you're going to talk about the R squared here. Your model can explain 84.9% of the variance in life expectancy. That's really, really strong. Okay? And it ran an ANOVA on the entire regression, checking the residuals, and they were significantly good. So that means you have a significant regression going on. That's good. And then here's your coefficient tables. The only thing you're going to look at here is your beta weights. Your beta weights and your partials and semi-partials basically list in order which one of these IVs is the biggest influencer on life expectancy. So the winner is the roommate variable. Okay, your beta weight is huge. So it means number one predictor of how long you're going to live is who you live with, how long you lived with somebody, right? Your number 2 is marriage. How happy are you in your marriage? Number 3 is how much alcohol do you drink? Number 4 is your health. And the very last one out of all these 5 is your social life, which we kind of knew from before. Social life is not a predictor of how long you're going to live. And you look at the last thing you're going to do is you're going to look at the collinearity to check to make sure 2 of your IVs are not behaving the same. And it's not. Oops, it is. No, it's just say it's not. Just say because your tolerance, if this number was less than 0.01, you'd be in trouble. Okay? And none of them are, so you're good. And that is it. Questions? Thank you. You're welcome.